what if we were to do carbon? Carbon, Roman numeral 1, right? Retrieve data. And here's the ground state of carbon. What did we say the ground state of carbon was? We talked about the ground term last time. We talked about deriving it from the 2p2 configuration. You have partially filled 2p orbital, 2p subshell with 2 electrons. Remember, you get your 2p2 configuration. It gives you 3 terms: a singlet D, singlet S, and a triplet P. Notice your triplet P is your ground state. Okay, and triplet P0 is the ground level, triplet P1, and then you have triplet P2 are your first and second excited state. Okay, and then so remember Hund's rule, maximum multiplicity among the terms that you can get from the ground configuration. The terms. All right, so one thing you'll find when we did carbon was that the term with the highest multiplicity is the one with the lower energy, right? One thing you'll also notice is if you have a level, triplet P0 had the lowest energy, so triplet P0 is lower in energy than triplet P1, which is lower energy than triplet P2. That's generally true if your partially filled subshell is less than half filled. Okay? If it's more than half filled, the order is actually reversed. So in other words, the A here, remember the proportionality constant in your spin-orbit interaction, that's a positive number. If it's more than half filled, your A is going to be a negative number. The order is going to be reversed. The highest J, okay, will have the lowest energy. Got it reversed. Will have the lowest energy. So for example, oxygen. Let's do a search for oxygen. What's the ground state of oxygen? Let's see if we can. What's the electron configuration for oxygen? 1s2, 2s2, 2p4, right? 2p4 is just like 2p2. Why? Because you have 1, 2, 3, 4, right? It's like you have, what do you expect the ground state to be? Maximum number of unpaired electrons you can have is 2. So if you have 2 unpaired electrons, what's the highest multiplicity? Maximum number of unpaired electrons plus 1 would give you the highest multiplicity. It's a triplet. It's just like you have 2, in the case of carbon, you have 2p2. Your ground state is a triplet. Okay? In fact, a P2 and a P4 will give you the same terms. Why is that? How many microstates do you have with a P2 term? Remember, you have 6 factorial divided by 2 factorial, 6 minus 2 factorial, right? So that's 6 factorial over 2 factorial, 4 factorial, which is 15. Okay. What if it's P4? Then it's going to be 6 factorial over 4 factorial, 2 factorial, the same thing, 15. Think about P4 as having 2 holes rather than 2 electrons. And so there's going to be 15 different ways of distributing those 2 holes, instead of 15 different ways of distributing 2 electrons. So there's really the same it gives you the same terms. Okay? So it will still give you a triplet P, a singlet D, and a singlet S, just like carbon. So let's look at the terms for oxygen. And what do you find? Okay, look at the case of oxygen. Triplet P is still the ground state, largest multiplicity, but look at the ground level. It's triplet P2. So triplet P2 has the lowest energy, followed by triplet P1, and then triplet P0. So the order is reversed for oxygen compared to carbon. They both have triplet P, and then you have singlet D and singlet S. You'll notice it's just like carbon, okay? But the order has switched for the J levels. So the highest J will have the lowest energy within a term if the valence subshell is more than half shell.